Hi friends, welcome to Ansel. So today is the 81st episode in the space series. So today we're going to discuss about a little thing known as the Roche limit. Yes, so first we're going to explain it quickly. So did you ever question why Saturn and many other planets in the solar system, all gas giants, have rings? Today we're going to explain how they are formed, what is the phenomenon behind that. Yes, so first let's start with a planet. P for planet. Okay, so next, so outside the planet there's a big zone depending on, so I will not put it as planet but big object, and then this one is they are pretty big, small object. Okay, so and both, yes, so they both, so first, so what happens is, if the so enters the Bohr's Roche limit, then it will suddenly start to divide. It will suddenly start to break up. Yes. So small pieces of it will be launched out from the main so body. Yes. So why does this happen? We're going to discuss all about that in this video itself. Yes. So this is also the main reason on why Saturn and many other planets have rings on them. Yes, it's all because of this limit, the Roche limit. Yes. So first, so the Roche limit depends on the mass of both of these objects, the mass of the big object and the mass of the small object. Yes. So if the big object has more mass, the size of the Roche limit will be bigger. But if the small object has more mass, the size of the Roche limit will be smaller. Yes, it will depend on the masses of both of the objects, the big object and small object. Yes. So yeah. So the small object will be completely obliterated. Yes. So first, how does this work? How do these small objects get obliterated just when they enter the Roche limit? Yes. So for every planet, every celestial body, there is a Roche limit, including stars, planets, even the smallest of asteroids. Everything has a Roche limit. Everything which is solid, that is, not gases like galaxies. Yes. Okay. So yeah, what happens is, because of tidal forces, the reason behind all of this is tidal forces. So what happens is, so the nearer side of So, which is nearer to Bohr, so that side has more gravity which is pushed on. Yes, so Bohr's gravity will just push that side of So. Meanwhile, the other one, it will just be free. No, it will not have enough gravity pull as the other side. So it will just start to rip apart because it doesn't know what to do. And then, boom, new rings could be formed. Yes. So yeah, every planet, including Earth, also has a Roche limit. Our moon just lies more than 100 times further than the Roche limit. Yeah. So now let's look at Saturn's Roche limit. Yes. So let's just remove this small So and increase. So this is Saturn. So this is Roche limit, a bit more bigger because it's a very massive object. Yes. So next we're going to put these rings in the green color. So when a small moon or any body comes into the Roche limit of Saturn or any gas giant or literally anything, it will just start to get obliterated by the Roche limit. So this could start to cause rings. Yes, so this is the reason why many planets have rings. Half of the planets have, all the gas giants have these rings. Yes, so rings are yeah. So, but if you know a bit more about Saturn's moons, there are still moons inside here. How did they survive? How are they living there without, even though they are in the Roche limit? The reason is, most of these moons inside Saturn's Roche limit are simply small. They're not big enough to be just turned into pieces of debris. They're very small. They don't even have a round shape. Venus is the largest of them, but everything else is just like a piece of rock. Yes, a very unusual shape, not a perfect sphere. Yes. So let's take an example. Prometheus. Yes, a small at the end, at the last ring of Saturn, the ring F. Yes. So Prometheus, as it is so small, it is not just attracted by gravity, but it is stuck together because of electromagnetic forces. Not gravity, but electromagnetic forces. If it was made out of gravity, Saturn's Roche limiter would have been like, hello, your death has arrived. Oh no, I'm going to die. So that is what Prometheus would have done if it had gravity to stick it in. But it doesn't have gravity to stick it. It only has electromagnetic forces to stay like that. And many other moons of Saturn are just like that. Yes. Okay. So but now, how are these rings stable without just falling into Saturn? And why are they just pretty smooth? Even though they are made out of very small rocks. The reason is these small moons known as shepherd moons. So for example, let's take an example. Yes. So there's a shepherd. He has some sheep, and he also has a shepherd dog. Yes. So he just lets his sheep just go around and just do anything, eat the grass around. But he has a shepherd dog. That means if he just does a whistle, then the dog comes and just tells the sheep to go and just settle. Yes. So just like that, these shepherd moons work. Here the shepherd dogs are shepherd moons. Then the sheep are the rings. And then the shepherd himself is Saturn or the planet. Yes, so these shepherd moons, using their very small gravity, will just try to keep these rings without going away. They try to keep these rings just stable, not breaking apart, just at least stable. Very good. Yes, these shepherd moons would have done a very good job, because without them, everything would be falling on Saturn, and Saturn would be as good as dead. Yeah. So yeah, this is for today about the Roche limit. Bye.